G'day everyone and welcome back to the channel. So I've made a few changes to this. I'm going to go over that first quickly. I'll just grab my bit of paper here. Just ignore the fact that I've written the same transistors here twice. Sometimes I do odd things. So I've changed my input transistors to KSA 992s. I'm aware that a lot of these transistors may no longer be in production anymore. This is just, I've got all the new transistors and all the old ones, and some of the old ones are better than some of the new ones. So, you know, not the really old ones, but a few years ago, some things that have been discontinued are very good transistors. Anyway, I'll show you the data sheets for these and why I've chosen them in a minute. So 2SA1024 is current. Well, let's just forget this current source and this fast transistor and just focus on this fast transistor, this current source, current mirrors, and current mirror, because the fast is going to have to change. We'll get to that in a minute. Well, it might. So 2SA1024 here and possibly here. KSA 992 for the input pair. Matched MPSA 42s for the current mirror. It's back to 4 transistor Wilson current mirror. I got it to work perfectly. By the way, the input pair is matched as well. Then over here, there's a 2SC3200 driving a 2SC3206 with a 2SA1024. Now, the problem with this, I've spent a lot of time over the last few days reading stuff, doing research, measuring components. I mean, I've been doing some insane things like measuring dissipation factor on capacitors, inductance of resistors. I've really been spending a lot of time. I'm just trying to take the auto lock off to take this up to the screen. I've been reading Doug Self's 6th edition amp book. I've been looking at a lot of different people's work. I like this the most so far. This guy that designed this, he's got the closest ideas to me, if that makes sense. Like you see, he's added some resistance in the power lines there. He's got separate current sources. He's used the 4 transistor Wilson mirror. He's added a collector resistor and a base resistor there, which is also something I ended up doing after doing more testing with transistors and trying to get THD down and stuff like that. He's also done 2-pole compensation, which I'm doing I'm doing that, but it's going to be 2-pole compensation with feedback compensate. So it'll be feedback compensated and 2-pole compensation. I can't think what it's called, but basically, the only difference is where this resistor goes to ground, it'll go back to feedback. I just can't remember where, if there's another capacitor or what. But yeah. Anyway, so I've been having a look at a few other people's designs. Some of them have already been on my computer screen for quite some time. You guys have seen them in other videos. Some of these are things I've worked on, some are other people's projects, some are, there's just a lot of random different things on here. But anyway, I've got a couple new ones on my phone too to put on the computer. But anyway, that's not important right now. What's important right now is my input stage is growing even more. I'm doing this to it. I was actually contemplating doing this a while ago. But what happened was I couldn't get the 4 transistor Wilson current mirror to function correctly. And because I couldn't get it to function correctly, I wanted to keep everything else more simple. But now that I've gotten that to function correctly and I've got nice transistors all matched and everything's working nice, I've decided to go for gold with everything, including the output stage. We'll get to that soon. There's not much getting changed on that. I mean, I already built that nice. Out of the transistors I had, I matched them the best I could. You know, all the components on there are chosen for low inductance and you know what I mean, low ESR. There's two capacitors that I'm going to change. I was going to originally do this, and I've decided to do it now that I'm putting so much effort into everything else. But basically, there's a couple of capacitors on the amp. Sorry, one sec. I'm just getting a schematic. Alright. These two 100 ohm resistors and these two 430 ohm resistors. Well, I never drew it in. Hold on. I'll just draw them in now quickly. My apologies. Very crudely drawn in, but... Alright, so that very crude capacitor just there, that's across these two resistors, and that one there. At the moment I've got a 10 nano and a 100 nano, and I've got, what do you call them? I've gone blank. MKT. I'm going to be putting, sorry, my neighbours are a bit loud. I'm going to be putting either MKS4, MKP4 or MKP10 capacitors in there. Haven't decided upon which one yet. Probably the MKP10s because they've got a really low dissipation factor. But yeah, anything that I can improve out of what I've got, I'm going to be improving. Okay, so now that brings me up to where I'm up to now. I eventually got, well, this working, but I also got the triple Darlington output stage hooked up. Just try and move that back so you can see the extra transistors in there. So they're back in there. I've added them and a Zoble network. What my problem turned out to be was actually, believe it or not, these diodes. So these diodes, I ended up having a look online. The forward voltage drop of the diodes I've got on the heatsink compared to these diodes works out with these diodes to be 1.2 volts more at just a couple of milliamps for the whole string, not per diode. But you can imagine how much that jacks up the bias. So this is going to look kind of funny because I've got two shorted over at the moment. But in actuality, I am using, wait, did I have three shorted over? Ah, man, I should have looked at where that wire was. No, I think that was going over three diodes. Yeah. Two, sorry. Oh, I don't know what I've done now. I'm going to have to turn this on and see if the bias is through the roof or... Oh, I think that's right. Anyway, let me just think about this. 1.2, 1.2, 1.2. Oh man, I'm going to have to look at the data sheet. I can't remember what the forward voltage was at 5 milliamps. But anyway, so once I knocked that down, I was able to get this to work with that. I have a new problem now. I have absolutely no gain. I mean, not no gain. So a few things to note. At first this was my mistake because whilst I had put 15k resistors for the feedback resistor and the resistor to ground, I'd forgotten to add the other feedback resistor, whatever you want to call it, R1, R2. I'd forgot to add R2 in the capacitor ground. So I've done that. There's a 1000 mic 16 volt Nichicon there and a 100 ohm resistor. So the feedback network's currently 15k 100 ohm and the 1000 mic to ground. The problem I've got is I can't get enough gain. So at the moment, this can only be turned up to 10 volts, and I'll show you what I mean. Let me just turn the power supplies on. Alright. What on earth is going on? Shit. You've got to be kidding me. I've just come in here for the day and something's wrong. Oh, you know what? Oh no. Oh, I probably just cooked my outputs. That bias string was wide open. And we're working with 120 volts here, so. Let's see how that goes. Yeah, no. Bye-bye. Bye-bye. Oh, and I just killed the other side now too. Well, at first it was NPN or PNP that was blown because when I turned one power supply off there was no current draw. Now there's current draw on one power supply, so I've just smoked both my output devices. Possibly the drivers. I guess I'm going to have to test the drivers. Ah, goodness. I'm off to a great start today. Now I've got some good news. So in probably 2-3 days at the most, and I mean at the most, I've got transistors arriving, lots of different types that I didn't already have here that I should have, like really common types, you know, like MJ15033s or 32, whatever they're called, I can't remember, and their counterpart. Things that I thought I had that I didn't have, and just random stuff. Oh, also some output devices. I got the NJW 1302s and 3281s, the 250 watt devices. I can't remember everything I've ordered, but I've got that stuff rocking up in a few days, and today a whole load of transistors that I ordered a week ago roughly rocked up. The reason why I'm mentioning this is because I've been held up on this. I'll explain why now. Where I'm up to is the VAS, and I need bigger transistors in the VAS, and I didn't have them. So that's why I'm happy that my transistor orders have rocked up today, because I can keep designing now. Let me guess, this one's good. Alright, we have our drivers still, but we lost the two outputs, which is what I thought looking at my supply. Alright, that's sorted out. I'll power it up again. And we have luck this time. That's nice. And not much offset. Alright, as you can see, I have this working with no offset adjust. That is going to drift in the opposite direction, I'm sure, but anyway. This is quite good considering they're not thermally matched. And they're not even properly matched. I mean, I did a quick job of matching just for the breadboard. When I build the amp, I'm going to clamp them to a heatsink, wait 5 minutes, very quickly test them without barely touching them. I mean, yeah, if I'm getting this sort of performance out of this circuit the way it is, that's really good, really good. Especially when you add up all the bits of wire and connections and breadboard tracks, which is just terrible, you know. Oh yeah, I've got something else that's arrived for the for this build, which is really good too. Let me just show you. Oh, sorry. So, I think I'll put the light on. Yes, that's better. Isn't that beautiful? Yes, that's aluminium. And yes, it's nice and thick. Wait till you see the rest. That's the side panels. Absolutely beautiful. Nice machining and everything. I'm quite impressed. I got this off AliExpress. That's why I'm so impressed. This is the back. But wait until you see the front. This is something. That is beautiful. You know, this is a piece of aluminium and it's got weight to it, which is quite amazing to me. And the finish on it's just beautiful. It looks amazing. I've just got a little bit of crap on it. See? Wonderful finish. So I'm very impressed with that. It did cost a bit. I'll tell you what, actually the case itself was a decent price. What pissed me off was how much I had to pay in shipping, and saying this and the thickness of everything else, I'm not so surprised now. But it comes with nice feet. 4 nice rubber feet. All the screws to put it together, obviously. The only thing I've got complaints about is this. And you're probably looking at this saying to yourself, well, Dave, what's wrong with that? You know, on first inspection, if you compare that to that and that, you probably couldn't tell any difference. Especially those two. In fact, you might think that they're the exact same connector. Well, you'd be quite wrong. Let me show you why. This is why I harvest these things. This is why I harvest as much stuff as I can. Let's get the old magnet. Let's go back here. Oh. Okay. Frickin' China. They can make everything out of steel. I swear to God. I just... All the bloody components I've bought off AliExpress have got steel legs. Except for the actual legit ones. But all the Chinese kit components, which I bought some more of when I bought... So the transistors that came in, some are AliExpress specials, some are not. Get in there. So anyway, I'm still going to use it. It's only an AC line socket, but yeah. Here's some of the transistors I got. As you can see, not AliExpress specials. Here's some more. And then, I don't know why I want to show you guys. So there's some AliExpress specials and some not AliExpress specials. And interestingly enough, some of these are my transistors in here. This isn't all from my order. But interestingly enough, there's some obvious copies here. And some of the other ones I don't think are copies. Anyway, that's all for that. I did replenish a few other things that are on the other side of the room, but that's neither here nor there. Let's get onto this. So I'm just going to turn the signal on, 1 kilohertz sine wave. That did not go well. Let me just turn that down. I might be missing a diode, I'm not sure. I don't seem to have crossover distortion. No, I just had my signal generator turned up too much. Alright, so now I can show you where we're up to now. So, as you can see, I got the sine wave nice and symmetrical. It's quite messy in terms of noise riding on it, but I'm talking about the fact that before it was skinny in certain places and thick in other places. Here is the problem. I hope everyone can see that voltage. Yeah. But this is where it gets even worse, right? Let me just zoom out so you can see the power supply at the same time, because power supply is current limited. Well, let's just turn this up one more and then turn it back down. before all hell breaks loose. Yeah, that's not good. And this is what's happening on the power supply as I turn it up. So I've got a really strong feeling that there's cross distortion here, because at the moment I haven't gotten up towards where it starts to break out in terrible clipping, and that current draw is going up quite substantially. We're already up to what, from 12 to 22 milliamps, and nothing's gone sour yet. So, and that's only at 1 kilohertz. So this is where I'm having trouble now. I've got a feeling that's just from mismatched devices, capacitance between breadboard traces, inductance in wires. You know, this is absolutely terrible. So what I'm thinking about doing is, now that I've got this working, finally, still low offset, very happy. That's without me putting effort in. You see what I mean when I say I like low offset. Wait until I get this on the board and match everything. Anyway, I don't really want to continue like this. So, a few things to note. The resistors that you put across your base, emitter to base lines on your emitter followers, these resistors that go from the NPN to PNP, and these resistors, they, you normally put suck out capacitors across to pull the charge out of the base of the transistors to help them switch off faster. When I try and add the suck out capacitors, it does not help the crossover distortion problem. Sorry, not crossover distortion, cross distortion. Sorry, my apologies. Now, I don't really get why that is. The other thing I've noticed too is if I take out one of these resistors and look at the scope, the sine wave cleans up. That's not supposed to work like that. So I've got a little bit going on here that's not right. So what I think I'm going to do is, in the entire time I've been messing around with this, I've probably only destroyed about 6 or 8 devices in total, like 2 or 3 pairs. Yeah, about 3 pairs, maybe 4 pairs of these tip 41s and tip 42s. Now, I'm currently limited at about 20 milliamps, thereabouts, 25 milliamps. I'm running 120 volts and they've got no heat sinks and they're small as. Now, if I've only destroyed bugger all doing this, I'm pretty comfortable putting my output stage on the same current limit, because, you know, it's going to be impossible to destroy that. Unless I do something really, really stupid, which I'm not going to. I do know what I'm doing, to the point that, you know, I'd have to make a terrible accident to do that. And I mean, let's face it, accidents can happen to the best of us, so it's... Anyway, I don't want to continue on with this anymore. So what I'm thinking about doing is a little bit more work on this bottom board. I want to add this complementary feedback input pair. Alright, if I sound like I've gone off topic, it's because I sort of have. Someone just knocked on my door, and after having a conversation, my head has forgotten where I was up to. Anyway, I know I'm up to adding this, so that's what I'm going to do now. Is I'm going to add this complementary feedback pair here to my input section, and then I think I'm going to leave it on breadboard for now, but I'm going to tidy everything up and make all the wires and everything tidy. And then I'll get the output devices, the output stage, whatever you want to call it, heatsink, over here, hook it up to that, and we'll see what we get. So I'll go rearrange this for the complementary feedback pair, set that up, and I'll be back momentarily. Sorry, I should just mention, because people probably want to know this, but at the moment I have 4 milliamps going through the input section and 4 milliamps going through the VAS. I am planning on increasing the input section to 5 or 6 milliamps when I put the complementary pair in. I'm thinking about 5 milliamps. I'm not sure, it might be 6. I'll have to do some calculations. It might even stay the same. I've got a funny feeling it's going to go up by 1 milliamp, not 2. I'll talk more about that after I've sorted it all out. I'd like you all to just pause the video and have a read of this section, but particularly this area here, and I think that has me sold. Sorry, I'm still reading. I'm sold. That's what we're doing. I'm not worried about gain on my input stage. That's not my problem. My input stage has got plenty of gain. In fact, I don't even think this is a problem with gain because, well, I think it's either the VAS is starved for current or the transistor in the VAS. You know, smaller transistors, if you run more current through them, lose their gain. Or is it bigger transistors? I mean, that's the thing. All transistors, I've gone blank on which one it is, but all transistors drop gain under load, right? Some just do it more than others. So what I'm getting at is this transistor here could have lost gain because of the current that's going through it. It might just not have enough gain, and it also might not have enough current. So it could be sort of a threefold thing, but it's probably more likely the fact that there's not enough current and a bit of the transistors losing gain because of the current going through it. And if I was to increase the current, I'd lose more gain, so that wouldn't really work out. I was just going to say something and I've gone blank. Man, 1 minute. That's all right, gain. Yeah, so I've got plenty of gain on the input stage. I've tested that, and also after this first emitter follower, Darlington, whatever you want to call it, beta enhanced transistor, there's tons of gain. So it's fast related. So if I lose a little bit of gain on the input side, it's not going to hurt me here. Also, I don't think that this is a lack of gain, because you say it comes up to where it's clipping and then the power supply current limits. I'd say it's hard clipping and cross distortion hitting at the same time, just dragging the rails down because it's in on a current limited supply. Not that you would do that to it without one, but I'm just saying I think that's what's stopping me from getting above 10.44 volts, not lack of gain. Alright, so I'll hook this up now and we'll see how it works. Sorry guys, there's just one other thing that I've forgot to mention. So down here where these two resistors are, as you see, the offset's really good with the 4 transistor current mirror. That's what it's supposed to do. Because the offset could be, you know, depending on the VBE and the gain of your devices and your circuit and all that, it could be perfect 0, above 0, below 0. Now, if it's above 0, you're going to want to trim this side down, and if it's below 0, you're going to want to trim this side. So what I'm going to do in the final schematic, I've done some math on this, and if you put, I think it was a 3K3 pot, I can't remember. I'll note the values on the schematic, but I just wanted to come here and explain why I'm doing this like I just did for the offset. So no matter which way it is, you can adjust it out with one of the 2 pots. I'll choose the pot to be a high enough value that it doesn't make the 68 ohm resistor any smaller, because that I've chosen these resistor values, the 82 and the 68, very carefully. That's not just off of another schematic or because it's what people use or something like that. No, I mean, actually most people use 100 on top and 100 or 82 on the bottom. No, I did that with careful measurements. So I don't want the values getting changed. So I'll talk about how I did that in a sec too, because that's interesting. So it's going to have to be a fairly high value pot so that it doesn't affect the value of the resistor, but I don't want to put really high value resistors all over the place either. So I think it's going to be about 3.3 to 4.7K. You can get 4.7K pots, and I'm pretty sure I've got some of them, and 5K pots. But yeah, one of the two, I guess. Or three if it's a 3.3K. I'll decide on it. Now, how did I decide upon these resistors? Right, well, I decided I wanted 150 millivolt drop across them. But the thing is, how do you work out the drop across them if you're A, bad at maths, and B, it's not working, amplifying a signal, or all the transistors are biased hard on or something like that? How do you know what the voltage drop is? Well, that's what I did. I basically worked out how big my signal is going to be coming in, gave it said signal, and measured the voltage drop across the resistors. Got them to roughly a couple hundred millivolts, and then started fine-tuning them, looking at the scope with the FFT up. I find the FFT is very helpful when you're building an amplifier, because different types of distortion manifest themselves as different what do you call it? You know, odd order, even order harmonics, and first order, second order, third order. And you can sit there and adjust the value of a resistor, or change a capacitor type, or change a transistor type whilst looking at your FFT, and literally whilst watching both the FFT and the sine wave, you can really see it change. Alright, I got some more schematics off of my phone that I've been looking at and put them on my computer. I just thought maybe you guys might be curious as well. What I'll do, because I know I flipped through the schematics fairly quick, I'll hold the phone over them for a couple of seconds each so that you guys can pause the video and study them if you so wish. Alright, let's go back to the internet browser and have a look at those ones. I'll just bring up one section of this at a time so that it's easy for people to see. That's all of this amplifier I've got. I don't have the whole amplifier on this computer. See, whenever I'm on a forum or I'm reading about something, if there's a picture of an amplifier that is being talked about, I always snapshot the picture. I just like looking over different designs. Obviously, I have my own ideas as well, but I like to have a look at different designs, including commercial stuff, because sometimes you see something that you like and you end up implementing it into your design, you know. I'm sure everyone recognises this one. I've still got to come back and fix this one. I'm thinking the only way I'm going to get it done with everything like testing good in it and appearing to work and a pretty small offset voltage, I think what I'm going to have to do is isolate stages. So, you know, disconnect all this input section from here, bias it artificially, test this stage on its own, test the safe operating area protection and the VAS. You know, isolate everything and test it. I think that's the only way I'm going to fix this thing. But anyway, we'll get there eventually. That's just out of Doug Self's book, I'm pretty sure. And there's the Hummingbird amp. If anyone's interested on the specifications for a Hummingbird, I'll show you. I find them a little bit hard to believe. I mean, yeah, no, okay, fair enough. 8 ohms, 32 volts, I believe that. Yeah, fair enough. I thought it had higher claims than that. No, that's quite believable. I thought it was claiming way better performance. I'm pretty surprised that it can do a 3 ohm. Oh, that's into a 3 ohm load. Yeah. Fair enough. Anyway, if you want to read the article, it's in a couple of magazines, but this is one of them. It's in Practical Electronics. What else is on here? Got the Soundtech amplifier schematic. And last but not least, this. Actually, I'll just zoom in on one section. Probably best like that. So there you go. There's a quick look at the schematics on my computer. This guy's taken it as far as to add a servo to his what do you call it? Your offset feedback circuit. I don't really like that. The reason for why I don't like that is if the servo fails, you end up with DC. So, yeah. Anyway, I'm going to do what I said I was going to do over here now, and we will pick back up. Alright, that is up and running. Offset is doing very good. Very good. As you can see, we've now got an input section that's comprised of only 9 transistors. If you want to know, I was thinking of doing something, this whole build process with the current sources. See, I don't like 2 transistor current sources for 2 reasons. One, they're noisy than LED based ones, and 2, they have problems with oscillation. These are really stable. And if you can supply the reference from a stable voltage, these work damn well. and that's what I wanted to do. But the only other winding on my transformer, it runs the fan, and I don't want to use that circuit to make a reference voltage, because I'd either have to add a lot of filtering and capacitance to the circuit to clean it up from the fan noise, or I'd be injecting fan noise into my current source, which would not be good. So let's not do that. Anyway, I've got all this hooked up. It's hooked up to the output stage and everything. It's all working. So I'm just going to turn my signal down and on. And hallelujah, that is working nicely. Let's see what the gain is. Ooh, that's not good. Oh, you know what? There's some compensation I'm pretty sure I should be adding to this. Yeah, it's still closing down at the same symptoms, around the same voltage. That's 10.8 volts there. If I go above that, the same thing happens. So I haven't lost gain, and I'll tell you now, I haven't done too much consideration on this, but Doug Self recommends using 2K2 resistors. Now, he's got 2.7 milliamps running through that current source, as you can see. And he says here, let me just read this out. A compromise is required in the complementary feedback pair circuit on the value of resistor collector, which sets the proportion of the standing current that goes through the NPN and PNP devices of each side of the stage. A higher value of collector resistor gives better linearity on this, but potentially more noise due to the lower collector current in the PNP devices that are the inputs of the input stage, as it were, causing them to perform less well with the relatively low source resistances. 2K2 seems to be a good compromise value for RC. It gives a collector current of 320 microamps. 320 microamps is not going to cut it for me. Now, I am running 4 milliamps in this leg, and I'm thinking about bumping it up to 5. So I would probably have, or if I use 2K2 resistors right now with the 4 milliamp source, I'd probably have about 500 microamps there, but that's still not enough. I want at least double that, 1 milliamp in each leg on the PNPs. So what I've done is I've put 1K resistors in there. I honestly think 2K2 is a little bit high. We'll see. These values can always be altered later on, but I'm going to have a little play around with it now. I've got some 2K2s right here. That's what I started with, but I changed it to 1K. I'm going to have a little play around with that, and then I'm going to do a little bit of reading, see if I can find any information on this subject online, and I'll come back and share my results with you. Then I'm going to replace those capacitors that I was talking about with the high quality capacitors on the output stage, and then I'm going to end this video, because this, as I've said, I'm basically happy with it now. So I want to get my output stage hooked up on the supplies and hooked up with this, and then continue working on the gain problem with an actual output stage that doesn't have a whole load of problems and missing parts, basically. Alright, the first thing I've been working on is offset, and what I've done is I've taken the 82 ohm resistors out the top, and I've put 47 in there, so now there's 47 on the top, 68 on the bottom. And as you can see, that you can't really get that any better, because it's going either side of 0, so it's centered around 0. I mean, what more do you want? So that's that. I'm going to investigate these 1K resistors now, and the current source value, and that's about it. One thing I have noticed is this appears to have a small oscillation happening. Okay. It's very, very small. I can just faintly see it. But it is there. too much noise to trigger on that. Yeah, anyway, it is there. Why am I up so high? Alright. Alright, I've had a little bit of a play around with it and I've had a little bit of a read, and I'm going to leave the 1K in for now, and I'm going to leave it set at 4 milliamps, and here's why. I can't really see any noticeable difference now at the point I'm at now. The more complicated the circuitry's gotten, the more the breadboard and the inductance of all the wires has come into play, and it's at the point now that I can't actually see through all the noise and oscillations and stuff. The only way around that would be to try and tidy this up, clean the breadboard contacts, you know, add filtering to everything. I'm not going to do that. So what I'm going to do is I'm going to either make up a board for this or put it together on proto board and pair that up with the output stage. I'm not going to do it on breadboard like this. It's reached the point where, I mean, to be honest with you, it was past the point of using breadboard quite a while ago, but I've got to design it. So I'm where I want to be for breadboard now. So I'm going to draw down in the schematic what I've got here. I'm just thinking about these bottom transistors that are in the current mirror. I'm using MPS A42s. I'm just considering using something a little bit better. I haven't decided upon that yet, so that's what I'm in the process of doing now. I'm going to do a little bit of research on that and see if there's any benefit in it. Obviously your input pair, whether it's just a normal input pair or a complementary feedback input pair like this, and your current source transistor, the quality of them matter greatly in an audio application, but I don't know about the current mirror transistors, if it actually, you know, their noise floor and their gain and stuff like that matters. So I'm going to research that quickly and update the schematic and possibly the transistors, and conclude that for this, it's going on to PCB. The other thing I've got to do is I've got to change these two capacitors and also two capacitors on the heatsink. I'll just go grab one of these. Ah, fuck. I just smashed my knee into the corner of a wooden table. These 200 nanofarad capacitors that are the charge suck out capacitors for the base junctions. I want to change them to better style of capacitor, basically speaking, and I'm not going to do this now because I did a little bit of reading on this, but it's either I can't remember the result I found, or there wasn't any information online about it, or there was mixed information, but I can't remember. But anyway, I've been thinking about using carbon film resistors here. I put the metal film in there because they're going to dissipate power and handle power well, but I don't know if that's going to cause any effects THD wise. I'm not too sure about that one, so that will be getting experimented with once we're up and running, basically. But for now, what I am going to do is I'm going to change these two capacitors and these two capacitors. I think for now, because I don't have a lot of those capacitors, I'm just going to do it on one of the amplifiers. I'm going to be building quite a few amplifiers. I'm going to be building quite a... I can see my scope. It's not good. I think I'm just going to turn this off for the meantime because it's just started oscillating and drawing twice the current it was drawing a minute ago. Yeah, I'm not going to leave that. Yeah, something's really happening here. Oh, that was it. It's this wire. No. What is it? I don't even know why I'm bothering worrying. Yeah, it's oscillating. I'm just going to turn this off. Alright, I'm going to move this aside, change these capacitors. Oh, that's what I was about to say. I think for now, well, I'll see how many caps I've got and what quality I've got, but if I don't have enough, I'll just do one amplifier, because I'm going to be building a few amps, probably about 3 fairly big amps, 500 to 1000 watt RMS. I'm going to be running subs off of one amp, mids off of another amp, woofers and mids, basically another amp might be running mids and tweeters. I haven't thought that out yet. I might be building 4-way speakers. I might be building 3-way speakers. I might be, I'll be bi-amping everything. So I need at least 3 amps to cut a long story short. I probably won't be running just tweeters off one amp. I probably have, passive crossovers on all my speakers, which is what I build. But I'll probably have some, what do you call it, fairly highly crossed over smaller mids running with my tweeters on one amp, and then another amp running some more lower crossed over bigger mids and some even lower crossed over bigger woofers, and then I'll have another amp running subs. I hope that makes sense. Anyway, so what I'm thinking is I'll put the most high quality parts in the amp that runs the tweeters, the medium quality stuff in the amp that does the mids, and the mediocre quality stuff, not in terms of power handling, of course, in the bass amps, because that's where I need the most power. But yeah, I'll probably end up upgrading them more as I get more parts. It's just that, for example, like MKP10, MKS4, MKP4, all those sorts of capacitors, I don't have very many of certain values, or any of them really. I've only got 6 of some value, 7 of another, 3 of another. So yeah. Anyway, we'll get this done now. Alright, so I've updated the schematic. I couldn't fit the input pairs there. I couldn't write it there. Actually, you know what? One sec. Alright, I don't know if this makes sense or not, but you know what? I've still forgotten something. I was going to go and research these current mirror transistors. I'll go do that now quickly. Sorry. Alright, I did a little bit of research and it turns out they do actually matter. So what I've done is I've put matched KSA 992s for the input pair. For the 4 transistor Wilson current mirror, I've used KSC 1845s. And here I've got the 2SC 3200 still, and I've got 2SA 1024 driving it. This is what I still have to decide upon, the 3206 and the 1024 up here. That's because I've got to work out the VAS still. The VAS is working like that now, I just don't have enough gain. So I've also added in the feedback components. This is a 2-pole compensation. So these 3 components are probably the final values. I've done a bit of research on that, and for the way this circuit is, that's probably going to be right. The thing that I want to experiment with though more, to be honest, I've left circles around them all because I am going to want to experiment with all of them, but I really want to experiment with these 2, the R and C across the feedback resistor and the R and C to ground. Now I've left out protection circuitry to clamp the base of this, and clipping diode in the feedback path to ground and all that sort of stuff, because I don't want it in this build. But I may end up revising this later on and adding even more to it. I think this is already quite complicated for what it is, so I don't want to make it too crazy. But yeah, so this is what I'm up to. And yeah, that's going to get made up either on a board or on some proto board. So now what I've got to do is move this off to the side, get some boards over here and some capacitors, and we've got to put better quality capacitors on the driver boards and output stage so that I can hook all this up. Well, I still got to make the boards, but you know me, I'm pretty good at making boards. I can get that done. So I did a little bit of thinking about these boards and these capacitors as well, and I'm going to leave them for now. In fact, I actually want to change them after the amp's up and running and I've got all the THD and everything down as low as I can, and leave that to one of the last tests. I'd be quite curious to see what sort of a difference it actually makes, if any at all. So I'm going to leave that, and I'm going to end this video here because I'm going to get started on board layout and making boards now. So that'll be another video. Yeah, alright, well, that's all I've got for now, so thank you for watching, and I'll see you all soon. Sorry guys, I forgot to mention this. I just added this in. There's going to be a jumper spot at the end of this 560 ohm resistor that comes off the 2-pole compensation, and it's going to be able to go to 0 volts or to the negative feedback. You know what else I've just realised? That's where the negative feedback goes, to that line there. So I hope that makes sense. Alright, thanks for watching.